Okay, so now we look at engineering notation and metric prefixes. As we said before, engineering notation is a subset of scientific notation. Everything using an exponential and a prefix is actually part of the scientific notation. But in engineering, we like to use those exponentials and those values that relate to an exponential in terms of a prefix. We like to use a factor of 3 or an exponent of 3. So if we take a look at some examples here, we have 82,000, 243,000, and 1,956,000. Okay, so in each case you can see, first off, just by inspection, we have 3 zeros, 3 zeros, 3 zeros. So in every case we have at least 10 cubed, okay, 10 to the third. So let's look at each one individually. So 82,000 can be expressed as 82 times 10 to the third. But you'll notice here, remember in scientific notation, we said the value had to be between 1 and 10. So now we're opening that up just a little bit. 1 and 10 is for scientific notation. In engineering notation, we want to make sure that our exponent is some denomination or some factor of 3. So we don't have to move the decimal point over 1 and add a exponent to 4 on here. We leave it as 82 times 10 to the third. And this is going to become important because when we start using then the next step, the metric prefixes, this allows us to use these alpha characters for milli and micro, etc., pico. In terms of the exponent, we can use the letter. So 82,000 becomes 82 times 10 cubed. 243,000 becomes 243 times 10 cubed. In the case of 1,956,000, you'll notice that we did move the decimal point all the way over 6 places so that we can end up using 10 to the 6th. So now looking the other way, now we're going to look at the decimal equivalents using the engineering notation. So in this case, we're going to look at what do I need to do to move this decimal point, 0.0022, over so that I get some factor of 10 to the third. Well, in this case, because we're moving the decimal point the other direction, we're going to end up with a negative exponent. So we've got 3 very small, I wouldn't say large, but very small values here where we have lots of zeros after the decimal point that we need to move into engineering notation and later into metric prefixes so they become much easier to handle. So in this case, if I move the decimal point 1, 2, 3 places, I end up with 2.2 times 10 to the minus third. In this case, I've got lots of places. I've got 3, I've got 6, I've got 9, okay? So we can move this all the way over to make this 47 times 10 to the minus ninth, which is a valid engineering exponential notation. The same thing with the last example. We're going to move it over 6 places this time so that we have 330. Now notice what we did. We added a 0. There's an understood 0 then right here behind that 33. We added the 0 and that allowed us to make it 10 to the minus 6, which we're going to find out later becomes micro. So those metric prefixes then become shortcuts for using the engineering notation. So you can see by this chart, we've got femto, pico, nano, micro, milli, kilo, mega, giga, tera. For those of you that are computer savvy or computer geeks, some of those metric prefixes should make sense to you. We are now in the realm of terabit. We've gone beyond gigabit for our capacity on our hard drive. So we can see how we use some of these metric prefixes. The symbols, because we don't want to spell this out every time, and in some cases we use a Greek symbol like mu to relate to a negative power. So 10 to the minus 6, 1/millionth becomes a micro, and we use mu for that value. Okay. So in looking at some examples here then where we can substitute the metric prefixes, 50,000 volts, 25 million volts, 0.00036 amps. Okay, that's a very small amount of amperage. We can move this decimal point around to make it make more sense. 1, 2, 3, 4, 5, 6, and we would end up with a very small micro amount. So in each case, 50,000 volts, 50 times 10 to the third becomes 50 kV. 25 million volts becomes ohms becomes 25 times 10 to the sixth ohms, or 25 mega ohms. And this value then becomes 36 times 10 to the minus 6. When I move that decimal point 6 places over, I get 36 microamps. Okay? So we can use the engineering notation and the metric prefixes in our calculators. All scientific and graphic calculators provide features for entering and displaying numbers in various formats. Scientific notation and engineering notation then are special cases of the exponential power of 10. Most calculators have a key labeled EE or EXP that's used to enter the exponent of the number. To enter a number in exponential notation, then enter the base number first, including the sign, and then press the EE or the EXP key, followed by the exponent, including the sign. So scientific and graphic calculators have displays for showing powers of 10. The thing to remember, every calculator is different. This description may not fit exactly to your description. The calculator that we recommend for our program is the Casio. It's the FX 115ES Plus. And the thing that you have to do is you've got to sit down and pull out the manual for your calculator and study it and do examples so that you understand how to make this calculator do what this is telling you. Okay, so other calculator displays the number with a small e followed by the exponent. So in this case, you see where on this one we had 47.0 and it actually showed what appears to be an exponent. In this case, it's telling you the e is the value raised for that exponent. Notice that the base 10 is not generally shown, but it's implied or represented by the e. Okay, so again, this text tells you check your owner's manual. So that gets us through the engineering notation and the metric prefixes. The next thing we're going to look at are metric unit conversions. Okay, so when we come back, metric unit conversions.